who Tom is, but Tom's been a member of this club longer than I have. I know he usually has a table over there. If you're like me, you walk by his table and say, wow, this is really cool stuff, but I'm buying radios, so I'm moving on. So I actually called Tom and said, can you do a talk for us, Tom? And he said, well, I'll look at my schedule. He's a busy man. And, but, you know, when we came down to discussing that, and I planned on originally having 4 talks in each of these corners, the other 3 people who want to will do a seminar after all said, well, I really want to see Tom. So it became pretty easy after that. I said, we'll do Tom from 12 to 1, and then people can pick one of the other 3 to go to after that. So there's some other good training courses, so check those out, but it's time, Tom.
Thank you, and I think we all owe Bruce a tremendous vote of thanks for the amazing amount of work and thought and creativity that he has put into this club. Charlie did wonderful things for the club for many, many years, and Bruce has come along and really done Charlie proud and doing beautiful stuff. So let's hear it for Bruce. Bruce, you are amazing. Now, let me take you inside the Enigma then. And my name is Tom Perera, and I started out as a kid at 15 years of age as a ham radio operator. And my parents had a lot of money, so I said, Daddy, I want a radio. He said, okay. Daddy, I want a Collins. Okay. I was one lucky kid. By the time I was 1 year older than this, look at what I had as a ham shack. You believe that? Look at that. That's a Helicopter's DD1 receiver. Hardly any of those were made. 2 front ends combined, 2 different antennas, wonderful rig Collins, Viking, but I did build all my transmitters. So I knew a little bit about electronics by the time I got through that. And I went to Columbia College, and I went to the psych department, and I said, you know, I know a lot about electronics. You guys need me? And they said, oh, yes, yes, yes. We're trying to understand the human brain. We're recording brain electrical signals, and we're having a lot of trouble with it. And I said, oh, electrical signals, I know about that. So they quickly hired me, and they also gave me a PhD, and I ended up as Tom Perera Professor at Columbia, if you can believe such a silly thing, teaching about the electrical activity of the brain. But we all know that the brain is really a big enigma. The enigma is the word for puzzle. So the brain is really a big puzzle. And I was teaching about it for 35 years at Columbia University while I was secretly trying to find Enigma machines. And when I retired, I could give my full time to hunting for Enigma. So let's take a look at the Enigma machine and see what it's all about. All branches of the German military used Enigma machines from 1928, 1929, right through the war. They needed to hide their communications because Hitler was building up the German military in contravention of the Treaty of Versailles. The Treaty of Versailles said no military for Germany, and Hitler built it up anyway, and the only way he could do that was to keep it secret with Enigma machines. The most serious, dangerous thing that Hitler did was to build up his U-boat command. The German U-boats or submarines actually sank 3,000 ships, killed 150,000 men, and sunk 15 million tons of shipping during World War II. So this was a very, very serious threat, and every single submarine, without exception, had an Enigma machine on board, actually 2 Enigma machines on board, to make their communication secret so that nobody could understand what they were saying. So before we get into the war and war history, let's look at the Enigma machine first. The Enigma machine was invented by a guy named Scherbius in 1918, right at the end of World War I. He tried to sell it to the military, and he also tried to sell it to corporations for internal security. He had this model, which was horrible, 300 pounds heavy and incredibly expensive. And the company said, hell, we're not going to do that. We can buy a code book, which has a translation into different code words, for for nothing, essentially. We're not going to spend that kind of money. So poor old Scherbius was left with these clunkers. They were so little sold that we've never actually found one. He then was convinced that he had to change his ways, and in 1922 he decided that he would build a portable version of the Enigma, and that portable version of the Enigma is what you see there, it's what you see on my table, and it remained stupidly unchanged throughout the entire war. The Germans never changed the Enigma design because they were convinced that it was absolutely impregnable, that nobody could possibly break the Enigma code. Here's what the Enigma looks like inside. It is modular. You have a keyboard, you have a light panel, a battery box over here, and a plug board on the front and some rotors. The Enigma machine is really very simple in operation. It is very similar to the code wheel. The code wheel is a device that dates back to Sky King. If you remember those cereal boxes, you buy a box of cereal and you got a code wheel in it. It actually dates before Sky King. This is Confederate States of America code wheel, and it was used by the Confederate Army to send secret messages. In order to understand the Enigma, I have to explain this code wheel a little bit to you. Let's encode my name, Tom, into a secret set of letters. First, we have to set the inner ring of the code wheel, which is rotatable, to a key position. Let's set it so that A is equal to H. We'll call that the encoding key. There are only 26 possibilities of the encoding key. A can be B, C, D, and so on. Only 26 possibilities. And we'll choose H. A is set to H. Now, when you do that, if you look at the first letter of my name, T, and find out what the coded version of that is, it becomes A. The O becomes V, and the M becomes T. My name has now become the coded letters A, V, T. You can take that A, V, T to another general in the Civil War, and people look at that A, V, T. What's that? What's that? Well, if the other general has a code wheel that is set to the decode key, which is the same as the encode key, A equals H, all that general has to do is look up A and say, oh, the first letter of the message is T. Look up V and it becomes O. Look up T and it becomes M. So this wheel is able to encode and decode messages letter by letter. And this is the basis of the Enigma machine. Good old Scherbius saw this technique, and what did he do? He did a brilliant thing. Instead of leaving the middle setting here, the rotation of that middle wheel the same every time you encode a letter, like T-O-M, what he did was to arrange a machine that would rotate the inner ring by an unprecedented number of steps to a new setting every time you encoded a letter. So you might encode the first letter as T is equal to A, but then the ring spins around and it might be that the O becomes an N and that the M becomes an S. Scherbius then developed a machine that was basically a code wheel, but that automatically spun the middle wheel of the code wheel. Here's the machine, here's the Enigma, and how does it work? Well, you type in the letter A on a keyboard, just like a keyboard on a typewriter. And you look for the letter that lights up after that. And in this case, you'll see that the letter that lights up after the letter A has been typed in is the letter H. The machine simply is a flashlight. It has a battery, it has a switch, and it has a light bulb. The only tricky thing is that there are a bunch of strange wires between the switch and the light bulb, and we'll look at the circuit diagram in a moment. But what happens here is that when you type in the letter A, the H light bulb lights up, and the Enigma operator, and there have to be two of them, write down the letter H, because the Enigma doesn't connect to anything. It simply lights up a light bulb. And so you have to write down the encoded versions of the letters. Here's the wiring diagram for an Enigma. It may look a little bit daunting at first. The battery is over here, and we're going to type the A key on the Enigma. We're going to press the A key. And what happens then, of course, is that the normally open contacts over here of the A key are going to close, and an electrical voltage is going to flow from the battery down through the A key to, in this case, the plug board on the front of the Enigma. The plug board is a place where letters can be connected over to another letter. So in this case, it comes into the plug board as a letter A, but it gets converted over to the letter M by a jumper wire. So we go over to M. Then the electrical voltage goes up to a set of rotors. And this is Scherbius's cleverness. These rotors rotate every time you type in a letter. So you get a different setting. The electrical voltage ends up at the leftmost wheel, which is not a rotor. There are only 3 rotors in this machine. And that wheel then connects it to an output line, and it goes back through the rotor. So it's gone through the rotors twice, comes out, and re-enters the plug board. When it enters the plug board, you can see another jumper wire goes from O to H, connecting the electrical voltage from O to H, and then finally the electrical voltage goes up through the normally closed contacts of the H key and lights up the H light bulb. Really a very simple circuit. It's DC, no RF, no complication. Here's a simpler view of the same circuit, just to ensure that you get the idea. We're going to push the A key up here, and that connects the battery voltage to the plug board. The plug board jumpers the A over to the letter O, and then runs that through the rotors and back out into the plug board letter M, which is then jumpered over to the letter H, and finally it lights up the H light bulb. So basically straight. You might want to take a few minutes to really understand that circuit, but it is a simple circuit. What I'd like you to notice in this circuit is that it is impossible for the A key to light up the A light bulb, because when you switch the A key on, the switch switches away from the A light bulb. And that was the Achilles heel of the Enigma. The Enigma machine had a basic flaw in its design, which made it impossible for the Enigma to encode a letter as the same letter. For instance, if you type in my first letter in my name, T, you could never light up the T light bulb. Look at the circuit diagram. Make sure you understand that typing in one letter cannot light up the same letter light bulb. The other thing I'd like you to notice in the Enigma is this beautiful reciprocity that is built into the design that to Scherbius made it worthwhile to give up that one flaw. And that is, if you were to press the H key, in this case, pressing the H key would follow the circuit from the H key. If you press the H key here, the electrical voltage from the battery is going to go back through exactly the same circuit, and it's going to light up the A light bulb. Okay? If you press the H key, it will light up the A light bulb. If you press the A key, it will light up the H light bulb. So the same Enigma or other Enigmas, if they're set to the same position with all the rotors in the same position, can both encode and decode a message. You don't have to do anything different in order to encode or decode the message. The critical thing is that they both be set to the same starting day's key. So again, to review, we press the letter A and we light up the light bulb H. If we have two Enigmas that are communicating with each other, we start out with the coding Enigma. We type in the letter A, the H light bulb lights up. But now we've got to get that H over to a receiving Enigma, some other radio station or military installation. We do that by sending it by telephone or by a messenger or by voice or Morse code radio. And the Germans were so absolutely certain that it was impossible for anybody to decode these messages that they did actually use plain old Morse code, sending the H, for instance, in plain old Morse code, or by voice radio, or over the telephone. And once that letter got into the other Enigma, as long as the other Enigma was set to the same starting key, typing in the letter H would light up the A and recover the initial A. So that's the way the machine worked. Now, the second time you press the letter A, we know the rotors are going to rotate up here, and you're going to get a different light bulb lighting up. As long as the original day's key has been set into the machine, then the second key press will light up an X. And to follow the X through military communications again, we type in the letter A a second time, we get X, we communicate the X over to another Enigma, type in the X, and we get back the A. One thing to remember is that the Enigma doesn't connect to anything. You have to write down these letters and communicate them to the other Enigma. And what makes this so special? Well, it turns out that the day's key, and remember I said that's very important, the initial setting of the Enigma is critically important. The day's key consists of a number of different settings of the Enigma. There are, for instance, 5 rotors from which you can pick 3 and fit them into the Enigma and put them in any position along the axle in the Enigma. And that means you have a total possible number of settings of just where the rotors are and what rotors are of 60. Each rotor has an internal ring setting of 26 possible settings, and that makes a total of 676 possible internal ring settings. The rotor initial starting positions, there are 17,576 of those. And if you look at this jumper cable matrix on the front, remember those little jumper cables we looked at? You can have anywhere from 0 to 13 cables plugging into the 26 sockets. And that makes 5 times 10 to the 15th possibilities. The total number of possibilities for a day's key in the Enigma then is, for a 3-rotor Army Enigma, 10 to the 114th power. And there are only 10 to the 80th power atoms in the entire observable universe. So the Germans were damn sure and certain that nobody would be able to figure out which one of the 10 to the 114th power possible days keys was being used on a given day, and they changed them every day. And they were right. It was darn near impossible to do that. Yes?
So how would they send out on the
I will tell you. Okay, so Karl Dönitz was certain of this, and he was head of the U-boats. And his job was to use his U-boats to sink other boats. And he was so absolutely certain that nobody could decode his messages, the U-boat messages, that he built a 1 million watt transmitter, the biggest radio transmitter that's ever been built. The antennas were a mile long, and it was very low frequency, 15 kilohertz. God, you could hear that. It was so powerful that you could see, in America, you could hang a little crystal radio up and hear this thing. It was so powerful that it blanketed the whole world with Enigma-coded messages. He was so confident that nobody could decode them, that he blasted them out to his submarines at unbelievable power levels. Here he is talking to his submarines by Enigma-coded messages with his 1 million watt transmitter. And the amazing thing about this was that people could intercept the messages. And the most amazing thing is that Dönitz was so certain that nobody would be able to decode the messages that he insisted that every single one of his submarines send its latitude and longitude location to him every day. So here the submarines, the German submarines, were giving away their positions, exactly where they were on the oceans every single day by radio using Enigma-coded messages. We already said that the U-boats were a tremendous danger during World War II, and the ability to control them was critical for Dönitz. He would tell them where to go. Yeah?
Why did they send numbers? There's no number.
Good point. Okay, if you wanted to send a number, you had to spell it out. E-I-N-S in German. And that was another clue that people could use. The number 1 was often used, and that helped in the decoding of the messages. Okay, so we got this terrible problem. The U-boats are sinking all our ships. What are we going to do? The war is practically lost. Along comes, if you saw the Imitation Game movie, Alan Turing to the rescue. He's going to save the day by cracking the Enigma code. It wasn't him, by the way. The only good thing about this picture is that that Enigma in the movie is my Enigma. I found it, restored it, and sold it to the people who loaned it to the movie company. So that was the good part. The bad part was the director wouldn't listen to truth. He wanted to make it apparent that Alan Turing had cracked the Enigma code. He didn't. He also wanted it to look as though Alan Turing had built the first Enigma deciphering bomba, as it was called. He didn't. Turing didn't build the first bomb by any means. Indeed, the first bomb was invented 6 years before Turing had anything to do with this. So both of these are lies. The rest of the movie is perfect. It's very well done, but these are a problem. So what really did happen? The real story of the deciphering of the Enigma depends upon 3 brilliant Polish mathematicians and the Polish Cipher Bureau, and they are the ones who did it. Poland split Germany. After World War I, the Treaty of Versailles gave the middle part of Germany to Poland. The Germans were not happy about that, and the Poles knew it. And they knew they were going to be the first people to be invaded at the beginning of World War II. And so consequently, they put tremendous amount of effort into their Cipher Bureau. They enlisted the work of these 3 brilliant mathematicians, Rejewski, Zygalski, and Rostiki, and they were the ones who first figured out the wiring of the military version of the Enigma and built the first Enigma deciphering machine, or bomb, the thing that Turing supposedly built in the movie. Okay? What do we mean by the wiring? Well, every rotor in the Enigma has what's called a rotor wiring maze. And that is, every input pin is connected to an output pin, input pin, output pin, but by way of sort of a random connection scheme. And the Polish mathematicians, by what is thought to be one of the greatest feats of mathematics ever performed, figured out the internal wiring of all of the Enigma rotors. Then they built an Enigma replica. They reconstructed the Enigma, and this is a Polish-built version of the Enigma, which they then used to help them to decipher the Enigma messages. And finally, they designed the machine in 1933, 6 years before Turing had anything to do with this at all, to decipher the Enigma messages. It consisted of 3 rotors and another 3 rotors, and they looked for electrical coincidence between the characters for certain words. And a little later on, they motorized it, and they put the stack of 3 rotors on top of this electric motor drive down there. And for 6 years, before Poland was invaded by Germany in 1939, the Poles were successfully deciphering the Enigma messages. In 1939, Poland was invaded by Germany. The British took over code breaking because the Poles actually carried their Enigma replicas and the bomb plans to England, sneaked them out of Poland by way of France and finally in Germany. And they gave this information to the British, who took over code breaking. Alan Turing took over the job of code breaking at that point and gave no credit to the Poles until 60 years later, in 1999, the British finally erected a little monument to the Polish mathematicians at Bletchley Park, where the British were breaking the codes, which said, oh, by the way, thanks, Poles, we appreciate the help in cracking the code. People estimate that Turing would have taken 6 years to actually crack the Enigma code, and the war would have been over by a year before Turing actually succeeded, if he had not had the bombs from the Polish mathematicians. The Enigma code was broken at Bletchley Park from 1939 on by Alan Turing and a tremendous group of 10,000 code breakers, and they were threatened with their life if they told anybody what they were doing. So they kept their secret for 30 years after the war. That means that nobody knew that the Enigma code had been broken until 30 years after the war. 1945 plus 30, 1975. It was not until 75 that people had any idea that the Enigma messages had been broken. That means that if you're a historian, since the Enigma deciphering was first revealed in 75, throw out any book on World War II history that is dated before 1975, because decoding the Enigma had a tremendous effect on the war, and none of the historians who wrote knowledgeable books knew that. And so their books are basically worthless. And of course, they don't want to hear that. They've written the definitive book on World War II, which was written in 1959 or something, and they get very upset about that. Even Karl Dönitz, the head of the U-boat command, refused to believe that the Enigma had been cracked. And I do some video interviews of Germans, and there's still people to this day in Germany who believe that the Enigma code was never broken, that it was a piece of British propaganda rather than a real breaking of the code. Alan Turing did great stuff. I do not mean to denigrate him in any way. He took over from the Poles. The Germans did change a lot of their techniques of using the Enigma, and therefore Alan Turing and his dramatically improved ability to have machines built was able to keep up with that. This is a bomb based on the Polish design. You can see rows of 3 rotors here, but much more elaborate. And this was designed by Turing and others at Bletchley Park. You look at the back of this thing, oh my God, and that's all relay circuitry. So it is amazing. Turing was also helped by the capture of code books from U-boats. If you got a code book was the way the Germans circulated the day's keys. They had a book and they put down the day's key with all those settings for every day of the month. And if you were able to get one of those code books, you could then read all of the Enigma messages for that entire month. And they typically circulated those books and gave them to U-boats. Most of the U-boats sank, but every once in a while they captured a U-boat, and that would help a lot. The repeated predictable words like Heil Hitler or Eins, the word for one, and many other discoveries and techniques were used. I don't have time to go into them all here. The best book, readable book on this is Seizing the Enigma by David Kahn. Yes?
Did Turing have anything to do with the breaking of the Lorenz cipher?
Yes, Turing was indeed active, and what he did was to invent an even more complicated machine than the Polish bombs, which he called Colossus, and which is thought to be one of the first computers, programmable computers, and that was involved in breaking the even more complicated machines that the Germans had developed at the very end of the war, using a high-speed paper tape, punch paper tape reader over there on the right. Okay, so here we are with Dönitz talking to all his submarines, and we're able to read the latitude and longitude of all those submarines. And probably it was just accidental sighting. But Dönitz did finally decide he better do something, and he added another rotor to the Enigma machine, made a 4-rotor Enigma machine. But the problem with that was there were a lot of politics in the German high command, and Goering, who was head of the Air Force, said, no, you cannot make a military Enigma for the Navy that we can't read with the 3-rotor Enigma in the Air Force. So what had to happen was Dönitz had to give in, and if you set a 4-rotor Enigma so that the leftmost rotor, the 4th rotor, is set at A, then electrically it becomes the same as a 3-rotor Enigma. That was a giveaway. The whole circuit was given away essentially, and it made it very easy to crack that machine. However, the submarines were also located by regular old direction finding, directional antennas, and of all incredibly stupid things, the submarines were all equipped with a radar detector, which would tell them whenever there were Allied ships around. And if they detected an Allied ship, they would submerge. What they didn't know was that their radar detector had an IF, which was a local oscillator, and it radiated its own homing signal. So the IF was not shielded in these things, and every time a submarine turned on a METOX, it was essentially saying, here I am, come and get me. And it didn't take the Allies long to do that. They found these signals, they homed in on them, they sank more submarines. So that was another way in which the German submarines were conquered. Now, Enigma machines were also sabotaged by the people who built them. The Germans were stupid enough to force Jewish prisoners of war to build the Enigma machine for them. Can you believe it? They had them assembling the Enigma machines, and the job was to build these machines, but the prisoners decided we're going to sabotage these machines. And one of the fun things that I have seen in my dissection of enigmas and restoration is the ways in which these prisoners sabotaged the enigmas. Here's one, a loose connector from the sticker board or plug board on the front just happens to be rattling around in the bottom of this Enigma. Now the critical thing is the Enigma has to work and pass inspection, but they want it to fail once it gets out in the field. So this thing rattles around, the Enigma passes inspection, and then sooner or later out in the field, it finds its way right under here. But see that big guard? It gets pressed down when you press a key on the keyboard. The key can't go all the way down when that's there, and the Enigma stops working. That's neat technique one. Here's another one. Can you see that fish hook? There's the point right there, that fish hook. I found a fish hook in the back of the plug board on one Enigma. The point of the fish hook gradually works it through the coating on here and shorts out the wires inside. Look at this. The plugs on the plug board have a large pin on the top, a small pin on the bottom, but I found some that had been wired with a small pin on the top, a large on the bottom. They wouldn't go in right, they wouldn't work right. Sabotage, wonderful. How about this one? This is a beauty. The screws that hold the wires down on the pins here have to scrunch down the wires really well. For that, you need a screw that is this length. If you put a screw that is this length in, it doesn't scrunch down the wire well. It leaves it a little bit loose, ergo flaky operation, ergo sabotage. Here's another one. The insulated coating on the wire runs by a sharp edge, which can work its way through. And finally, I found that some of the screws were coated in a compound which is non-conductive. I took the screw out and rubbed it. You could see this white stuff. The white stuff is non-conductive, and I found some screws holding the wires into the connectors that had no electrical continuity between the screw and the pin. So another great way of sabotaging. Now, at the end of the war, Germany ordered the destruction of every Enigma machine. Hitler said every machine must be destroyed. They had to blow them up, destroy them, throw them in lakes, and so on. And then, after the end of the war, strangely, Churchill ordered the destruction of every single Enigma machine and deciphering bomb and all of the plans and papers. Why would Churchill order the destruction of every Enigma machine? Okay, this was a puzzle for 30 years for us, 40 years, and only last year we discovered the answer. And the way we discovered the answer is interesting. Here, for instance, is an Enigma that's been blown up in the prescribed way. You put a hand grenade in the middle and set it off and run like hell, and the Enigma machine becomes junk. And you'll see some Enigma machines up here at the front of the table that were destroyed either in that way or in battlefield. The discovery of an Enigma machine with a Hebrew keyboard blew our minds. We had no idea why a German Enigma machine would have a Hebrew keyboard. And so we decided we had to do a great deal of research on this. And we finally discovered through the FOIA, Freedom of Information Act, that Churchill had given 30 Enigma machines to Israel at the end of the war. But he had forgotten to tell them that the British had learned how to decipher the Enigma machines. So he had essentially given them a Trojan horse. And he expected the Israeli military would use these machines, and therefore the British would be able to read all of the secret Israeli military messages. However, he didn't realize that a man who had been working at Bletchley Park had come back to Israel. He saw that the Israelis had changed the keyboards over so they could use them with Hebrew letters. And he couldn't actually reveal to Ben-Gurion that the Enigma machines were cracked and that they could be read. So what he did was he said, have you ever heard the story of the Trojan horse? And Ben-Gurion got the message, and they were never used in Israel. But the Enigmas were also given to Spain, to several South American countries, and a number of other countries. And the British, therefore, were able to read the Enigma messages throughout the war, even though everybody thought that they had destroyed all of their Enigma decoding machines. So an interesting finding. Here's a typical battlefield Enigma. You find them sometimes on the surface. Up in the front of the room at the end of the talk, come and take a look at one that we dug up out of the Battle of Stalingrad, the battlefield there. They're usually in pretty bad condition. Digging in these battlefields is horrendously difficult. This is almost quicksand here. You sink in to this horrible mud stuff. You have to use a metal locator, and there's always the chance that you're going to pick up a live hand grenade and it goes off in your hand. So it's not for sissies, but it's really fascinating to do it. Here are some battlefield found parts of Enigmas, and sometimes we find Enigmas like this. The one at the front of the room here is very similar, and they give us clues as to what happened to the Enigmas. If you look closely at this machine compared to a restored Enigma, you see that there's a lot of damage on it, and if you look more closely at the damage, you can sometimes find a bullet hole. There's a bullet hole right there. By measuring the diameter of the bullet hole, we could determine that it was a pistol that fired the shot, and pretty much only officers carried pistols, so it was likely that an officer had tried to destroy this Enigma. You can trace the path of the bullet through one of the rotors and down to the bottom there. You learn quite a bit about this. Here's 4 bullet holes. You'll see this plate up in the front of the room, again made by a 7.65 bullet, which is typically a pistol bullet. Here is a lake. And the lakes in Germany are beautiful and all that, but we found that this lake, people were telling us that the Germans had thrown things into this lake at the end of the war. And that, of course, got us very excited. We got ourselves gussied up and we went down to this lake, and we decided we'd go diving in the lake. But when you look at the lake, you realize that the visibility is no more than 1 inch. So if you're diving in this lake, you can only see 1 inch in front of the faceplate of your mask. Nevertheless, Enigmas beckon, so we got ourselves an underwater metal locator that did not require seeing anything. You put earphones on, it goes beep, beep, beep when you put the search coil near something metal. And we went down into this lake and started hunting around and bringing up pieces of metal. Again, not the smartest thing to do because some of those might have been live. We did find parts of a torpedo. We found a number of German radios, and we found an Enigma machine. Doesn't look much like an Enigma, does it? But it is indeed an Enigma machine. The man who was operating the metal locator at that point got so excited when he realized that he had an Enigma machine. Take the metal locator, you sort of feel what it is that's the end of the metal locator. He dropped the metal locator, grabbed the Enigma, and headed for the surface, and we've never found the metal metal locator after that. Unfortunate, but it was worth it. We ended up with this great treasure, which is an Enigma machine that has been underwater for 70 years, and we learned a number of things. First of all, the Germans loved to kick in the front of an Enigma machine. That was a quick way to destroy the plug board. Then we saw this bend here, and we could tell that that had been made by something other than a boot dropping down on it. Finally, I have a friend who has a German Mauser rifle, and I fitted the Mauser rifle right into this bend here, and I could find that it was exactly been made by a Mauser rifle being banged into the Enigma. So the guy, before he threw this thing in the lake, had kicked in the front, and he had hit it with the Mauser rifle. He also shot a hole through the battery box, which is in there. So we learn a lot. Here's a submarine that was sunk off the coast of North Carolina, U-352, and it was an active submarine. It is now an interesting dive site, quite deep and a little dangerous to dive. But if you go inside the submarine, you know that every single U-boat had an Enigma on board. So it's well worth penetrating the submarine, going after the Enigma, but it is exceptionally, exceptionally dangerous to go into a submarine with scuba gear. Big ships, okay, they have big doors. Submarine, you have to fit yourself and your two tanks through a little round opening like that, and that's not a lot of fun. I don't do that. I like big open dive sites, not something like this. But the guy who went into this submarine finally managed to recover the Enigma. The Enigma, I'm not sure it was worth the risk, but that's the way an Enigma machine looks after it's been underwater for a period of 70 years, 65, 70 years. Not in great shape, but you can still clean it, and you can tell it's an Enigma, and it's a great museum display. Here's another Enigma that was just brought up last year from the submarine supply vessel Ammerland in the Baltic Sea. This one we haven't even taken out of the water yet, still undergoing conservation. Every once in a while you find an Enigma that wasn't destroyed. And this is what I hunt for. I have a team of people in Germany that help me. They're always looking for this. And this guy had an Enigma. What typically happened at the end of the war was that the Germans heard about Churchill's destroy on-site order, and the officer said, oh, maybe the Enigma has some value. I'll take that home. And they take it home, and then they forget about it, and they die, and the family has this thing in the attic that looks like a typewriter, and that's our job, to find them. Well, this guy knew what it was. This guy is a German. He is restoring this thing he's sitting in, which is a German Me-109 fighter plane. And he needed a motor for his fighter plane, and I needed a four-rotor Enigma, which he had in his hands there. And so we dickered a little bit, and I ended up with his Enigma, and he ended up with enough money to buy the motor for his fighter plane. He swore he was going to fly that thing. Just a terrifying thought. Anyway, he was one of the nutty people that you meet in Germany when you're hunting for these. Here's another guy. He had an Enigma. We found this guy who said, sure, I'll sell you an Enigma, come on over. And he spent maybe 15, 20 minutes talking about his favorite machine gun. Yeah. And at one point he said, you know, you're in America. And 50 years ago, I would have shot you right between the eyes. And I could almost feel the bullet when he did that. Scary moment, oh my God. And then he put this big smile on. He said, ha, and here I am selling you an Enigma machine. This is amazing stuff. But it's a lot of fun to do. It's much more fun than deer hunting, I'll tell you. Okay, so anyway, here is another thing that we found just a month ago. An Enigma that has been cut out with another rotor in, making 5 rotor, never went into production. We're always finding these weird modifications of Enigmas. We're trying to put together the history, understand the Enigma history. This is the moment, the moment of ecstasy for an Enigma hunter. This is what could I say? I'm going to this guy's living room, and he says, yes, I have a few Enigmas here. He reaches down at one 2, 3 enigmas come out from under his cabinet in the living room. I'm just about ready to pass out. That enigma right there is the one that ended up in the Imitation Game movie. So you are seeing the exact moment of first discovery of the enigma that ended up in the Imitation Game. Excited? Oh, I can't tell you. The enigma, of course, required that we disassemble it and clean it. We eventually sold it to Bletchley Park. We've sold a total of 3 enigmas to Bletchley Park, and they then loaned it to the movie. But it's so much fun to see this enigma that I found and restored on the big screen. Great fun. Now, what about the value of enigmas? We've said that 20,000 enigmas were made initially. We think there are about 300 enigmas left in the entire world, and little by little the values have been going up. In 2012, $265,000 was paid for one. 2014, $365,000 was paid for one. This year, in 2017, somebody paid $565,000 for one, and we have one coming up at auction in December, and we have our fingers crossed. May it sell big. We will see. But it's a heck of a good investment anyway. What kind of nuts buy enigmas for that kind of money? Well, a man who made a tremendous amount of money bought one from me, and he loaned it on sort of a semi-permanent loan to the Chatham Marconi Museum in Chatham. So a number of our enigmas go to museums. This man over here, Chatham, this man over here was the former CEO or executive officer for technology at Apple Computing. And he's very happy with his enigma to the point where he put it on his Christmas card. You have to be a little nutty to buy an enigma. We've sold enigmas to people with Ferrari collections. We've sold enigmas to all kinds of people. Most of them computer security people want something, although we did sell one to the police, the South Korean Police Department, to put on display in the South Korean police headquarters where nobody's allowed in. It's very peculiar. You know, all kinds of strange stories about that. No time to go into them. Here's a bunch of historians, people like me who are really into trying to reconstruct the history. We got together at Bletchley Park. That's me over there, a little more hair. And some of our Enigma machines in the front. We're always working to improve our knowledge. Very quickly, the Americans used their version of the Enigma, which is a purely mechanical machine. You'll see one of those up here. It's very interesting, all mechanical, and you'll notice that the pitch of the letters on these rotors is different. So it adds complexity to the enciphering of this machine. You set a letter up here, you crank a crank over here, and it prints out the enciphered message over there. This is a Russian Cold War cipher machine that is still in use by the Russian military. Some branches, they're retiring out most of them, but it is extremely complex. And if you look at it, you'll notice that there are 10 rotors instead of the Enigma machine's 3 rotors or 4 rotors. The rotors counter-rotate. Each one operates in a direction opposite to its neighbor. There's a paper card that is read in over here that replaces the plug board. But this is the latest technology of code machine for Russia, and a very, very complex machine. The Russians are trying to phase them out, but before they phased them out, I was able to get one. And the way I got it was some guy sneaked into a military base, apparently, and managed to grab one off the bottom of a fire. Fires generally burn up, and so he grabbed the machine at the very bottom of the fire, and you can actually see the singe marks on the machine and on the power supply up here. One more thing I want to mention, and that is the latest cipher machine that's being used by the American military, and that is the Harris RF310M. It is a handy-talkie or walkie-talkie, but it includes a complete Enigma machine inside it. I have one of those at the front table. If you look at any of the pictures of Afghanistan, current pictures, you'll see these. The arrows point to this one, this one, this one, and this one. It is currently being used by the military, and I thought you might like to see what they look like and take a heft of it. It's really quite heavy, but it's also technically very interesting. So here I am with a Harris on the left and a World War II walkie-talkie on the right. The difference is the Harris is encoded and the right-hand walkie-talkie is not. The right-hand, the World War II walkie-talkies, by the way, were detuned on purpose so that the GIs wouldn't give away important stuff. They only had a very limited range. So I'll go back to tinkering with my enigmas. Thank you for your attention. I'll answer any questions that I can in the 3 minutes or so that I have left. And thanks for your attention. Yes?
Okay, on the Harris transceiver.
Yeah.
Is the encoding audio, or is it just when you do
It's
text?
digital. The audio becomes digital, and the digital is further. Yes, back there.
On the 3-rotor machine, so for each keystroke, the rotors rotate?
Yes, one step. When I get done, come up and use it, and you'll see this happening.
So if I type PTT, I wouldn't get the same answer?
That's right. You'll get a different letter every time, yes.
The metal detectors that were used toward the bottom of German lakes in Germany,
Yeah.
would they have been able to detect sunken gold in wooden boxes?
Yes, you can set them to different settings for different metals.
And they can detect gold?
It could detect gold easily. Yes, it's a metal. Yes.
From my understanding, there, on the net, there is an Enigma emulator.
Yeah,
Okay?
wonderful.
So,
May I just stop here for a second?
Sure.
You can download into your computer and into your smartphone an Enigma simulator emulator that is exact, accurate, and looks like an Enigma. You don't have to spend $200,000. They are free. So just Google Enigma simulator. They are completely interchangeable. Everything you encode with one of those, you can decode with a real Enigma.
okay, so that leads me to my question. Presumably, the same thing can be done with the Russian Fialka.
Yes, but the Russian Fialka is incredibly complicated, and uniquely, it is capable of encoding a letter as the same letter. The way it does that is boggling, mind-boggling. Yes?
Since the encoder and decoder depend on a radio wave in between, is there problems with synchronization if your radio signal is weak?
No, it's all digital for the modern stuff, and in the old days, it was just words anyway, so there was no problem. But now it's digital, and digital can have self-correcting codes so that it makes up for any errors.
Which country's Navy was the first to get their hands on either a code book or an enigma from a submarine?
I think it was the British who were able to recover, I'm quite sure it was the British who were able to recover the first code book. But it was long, 6 years after the Poles had done all of their work. It was in the time of Turing. Anybody else? Yes.
What happened to the 3 Polish mathematicians during and after the war?
They escaped by the skin of their teeth from Poland with their Enigma replica. They went through just horrible stuff getting out of Poland into France, and they finally made it over to England. One of them was killed in a ship when he was sent down to North Africa to help. But the horrible thing about it is that these brilliant Poles who gave the key to the Enigma to the British, are you ready for this, were never, ever allowed in Bletchley Park. They were forbidden to do any further code breaking because the British thought they were a security risk, for God's sake. So please spread the word. It was the Poles and not the British who broke the code. Everything else, the British did great stuff, but that's really a travesty. Anybody else? Yes, way back.
How did they transmit the keys?
When did the Germans what?
How did they transmit the keys? You know, the keys?
How did they transmit the key? They went through many different iterations of that. If they didn't use the code book, they sent 3 letters, which were then to be encoded by a receiving Enigma and sent back to them, which then were decoded. And so there was a kind of a handshaking exchange of these 3 letters that were the starting part of the day's key. But you really have to read David Kahn, because there were 10 or 20 different techniques like that that they used to send the key by radio. If they weren't using the code book, they sent it by radio. Okay, anybody else?
One more question, anybody?
Yes.
Why do the Russians, or why do we even use something like Enigma machines today instead of the secure connection system of factoring very large private numbers?
I'm not a cryptologist, so I can't really answer the relative merits of private something cryptology, PSP, versus the Enigma, but I'm sure you could read about that. I'm sorry, I really don't know enough to answer
But
that.
there must be some reason, because otherwise the other systems useless.
Any idea? Anybody? Okay. Well, thank you all. Please come up and play.